Good morning, everybody at home. I'll just assume everybody at home can hear me, correct?
Yeah.
Okay, thank you. All right, so the last 2 days we were working on talking about domain and range because we're going to continue looking at domain and range with the special functions. So we're going to perform operations on functions and do something called a composition of functions today. So we're going to work with domain and range, but looking at the equation instead of relying on the graph, like the second half of the homework. So that is kind of like what our goal will be, to now use the equation to find specifically the domain of the function. And that'll be something that we continue to focus on throughout the next coming chapters. And then you'll just continue to work with domain and range pretty much through math, because it kind of describes a function, and it, in the end, it helps us find other parts of the function to kind of narrow in and know what to look at. So we are going to be adding, subtracting, multiplying, and dividing functions today. So we're going to take these functions and try and combine two functions together by performing operations on them. And then we will be finding the domain of these new functions we create. There are some book problems, 3 to 19. I would say these problems are not long and involved. They don't require a lot of work. But please make sure you're showing me something so that I don't just see the problem and the answer. But really, they are minimal work. And then 58 or 48 to 53, those are some review problems. I try and throw in some spiral review every once in a while, just to keep you fresh on factoring or fresh on solving an equation for X, just to kind of pull those pieces in, because we will be building to that as we get to the end of the chapter. So we will be solving for X with the new functions, these radical functions that we're working with. Does anybody have questions on the domain and range worksheet from yesterday? Okay. So then we're going to start in the notes, section 6.3. We will spend today and Monday on it. Pretty much each of the sections, there's 6 sections in chapter 6. So we'll pretty much spend 2 days on each of those. So today, Monday, we'll do 6.3, Tuesday, Wednesday, 6.4, Thursday, Friday, next week, 6.5. Right now, it's looking like there will be a chapter 6 test, not the week of Valentine's Day, but probably the week after. You guys have President's Day off, so it'll probably be like the Monday after that. You have a 4-day week. So I don't know, that might be like the 22nd, something like that. So it's still a little ways off, because we do have a couple of sections to kind of cover. But 2 days per section. So just to give yourself an idea of the pacing for the rest of this chapter, figure 2 days a section, 2 days to review. So a power function is the term we're going to talk about, because really we have been working with power functions. So we'll kind of give it a formal definition. And then the functions that we work with today will contain powers or exponents. That's what we've been working on, trying to talk about. So a power function is a function in the form y equals a b to the x. So remember, a function, we said yesterday and the day before, it has to pass the vertical line test, but each x has one y. And actually, I guess since it's a function, let me write it in function notation. Once you have the f of x notation, whatever equation you have is a function. Each x has exactly one y. So there are two letters in here, the A and the B, and then we have an X as well. So A is a real number and B is a real number. My brain is like thinking together. X is a rational number, which are the numbers we've been working with. So just as an example, we may see something like 4x and then maybe to the 1/2. So that could be an example of a power function. So it has some kind of exponent or power. But those powers could be squared, it could be a half, it could be a cube. And it's of the form f of x. So we've been working with, God bless you, expressions that have powers. Now we're calling it a function because we're setting it equal to f of x. That's pretty much all we're doing here. So we are going to do some operations on basic functions, linear functions, and then we're going to try and do some operations on these power functions. So we have two functions that are given. It says let f and g be any two functions. A new function h can be defined by performing any of the four basic operations. So pretty much between first, second, and third grade, you learn to add, subtract, multiply, and divide. Those are the four basic operations of math. I mean, anything that you do in math usually contains one of those four operations. So we are going to now take two functions and perform those operations with the functions to create a new function, and it's being called h. So h just represents a new equation or function that we created. So in this example, we are going to use these two functions, 3x for f of x and x plus 3 for g of x. So those are two functions. We're going to perform the four operations to combine them together to create a new function. So the first one is the addition operation. And that says my function h of x can be found by taking f of x plus g of x. So if I want to find this new function, literally I'm taking the equation for f of x and the equation for g of x. And you add them together because it says it's the addition of two functions. So Grace, if we take f of x and add it to g of x, what's the new function we create? Yeah. So if you combine those x's, what do you get? So we're adding them. So 3x and x makes, you're thinking way too hard for a Friday. How about 4x plus 3? Yep, no, it's okay. You're fine. I think you're probably thinking like it should be harder. It seems like it should be harder because it sounds so fancy, but you're just adding like terms. So our new function h of x is equal to 4x plus 3. It can be found by adding the two functions together. And that's it. So not too hard, add your like terms. You now created a new function by adding the two given equations or two given functions together. So we're going to do the same thing with subtraction. We're going to subtract the two functions. So I have f of x, which is 3x. We are subtracting, and I'm making that minus sign big, emphasizing the fact that we are subtracting. And we're subtracting g of x, and g of x is x plus 3. Now, I will say right now, 75% of you are going to get this wrong in the test. That's pretty bold of me to say that. I've been teaching for a long time, though. That x plus 3 is a quantity. It's grouped together, and both of those terms make the function g of x. When you subtract, you have to subtract the entire function, not just the first term of the function. So we're subtracting all of g of x. So Jaden, what does that mean if I'm subtracting all of g of x? Exactly. So you have to subtract both x and the 3. So this is really saying you have 3x minus x minus 3. So right now I'm telling you 75% of you will not subtract that 3. Wrong one. This guy right here. You'll subtract the x, but you'll add the 3. Prove me wrong. Be the first class to prove me wrong. That would be wonderful. So make sure you're distributing that negative through because you're subtracting the entire function. Jaden, what is our new h of x function then? So 3 minus 1 is 2x, and then just minus 3. So combine the x's together and then minus 3. So if you have a quantity, make sure you're subtracting all of that second function. Eva.
So for the addition, just to like keep it straight in your brain, can you put parentheses?
Most definitely. To group them together, we can place parentheses around this to keep it straight in your brain to show that you've got one function separate from the other. Exactly. Other questions? Just so that you can see that you have that whole function that's grouped together, the x plus 3. All right, so let's look at the third operation. You'll first learn addition, then you learn subtraction, and then you go to multiplication. So in multiplication, we have f of x times g of x. So take your f of x function, which is 3x. I'm going to use those parentheses to show that it's grouped together. We're multiplying that by x plus 3. There's my second function. Now these guys are being multiplied together. So my first function is 3x. My second function is the quantity x plus 3. Gabby Soul, how do you think you'd multiply those together? Yeah. So our new function, 3x squared plus 9x. So you can see one function in front, the second function in parentheses being multiplied, distribute it through, you create a new h of x function. So the last one is division. And it says we are taking f of x and dividing it by g of x. So we have our f of x function. We're dividing that by the g of x function. Again, that's a quantity. It's grouped together as x plus 3. Now, here's the other trick, or how students get tricked. People like to get cancel happy. You want to just cancel things out. But remember, this is a fraction. And what you do to one thing in the fraction, you have to be able to do to all pieces of the fraction. So yes, the 3x has an x, and there's an x plus 3 in the denominator, but there is not an x with the other 3. So I cannot cancel out one of the x's or a pair of the x's if I can't do it to all of them. And it may help if you keep it grouped together in parentheses for your brain to think that they have to stay together as a group. So this actually cannot be divided. It cannot be simplified. Sometimes division is really just showing it as a fraction. In math, this is considered division. So you might think, yeah, but it's a fraction form, but that is a division bar as well. 1 divided by 2, or in this case, 3x divided by the quantity x plus 3. So that is as far as it's simplified. There's nothing else for you to do. Questions? So before we move to the next slide, I said we were going to be talking about domain. It says the domain of h, which is our new function. So the domain of the new function consists of all of the x values that are in the domains of the original functions f of x. I made that in purple. Keep purple here. And g of x. So the domain of the new function that you create actually uses the domain of the original two functions. With the one exception, the domain of a quotient, which is our fraction, does not include x values for which the g of x function is equal to 0. Remember, when you have a fraction, you cannot have a 0 in the denominator. So before we move to the next page, we're going to go back up and look at our original two functions. And I want you to state the domain of the original two functions. So my first function is 3x. What's the domain of f of x equals 3x? So think, what type of exponent does it have? What type of graph would it make? What would its domain be? So this really has an exponent of a 1. Jaden? Yeah, negative infinity, God bless you, to positive infinity. Because this is an odd power. It's an odd degree function. So Jaden, looking at g of x, it says x plus 3. Its exponent is still a 1. So that domain is also, yeah, the plus 3 has no effect on the domain. It doesn't change it. It's the exponent of the x that's making it an odd function. So because both of those domains are the same, this is saying that the domain of the new function that you make will be the domain of the original functions. So this domain is negative infinity to positive infinity. Because my original domains were negative infinity to positive infinity. My domain of the subtraction problem is negative infinity to positive infinity. My domain of the multiplication problem is negative infinity to positive infinity. There is one exception, and that's the last one because it's a fraction. The domain of a quotient does not include x values for which g of x is equal to 0. G of x is our denominator. That denominator cannot equal 0. That's what we talked about yesterday. So that means x can't be what number for this last function, Brooke? It can't be negative 3. So Brooke, how would we write the domain then of that last function if it cannot be negative 3? There you go. I know, lots of stuff to say. So the only domain that changes for all of these is the last one, because you're still using the same original functions. So if my two functions to start with were the same, then all of the domains will be the same except the last one because it's a fraction. Questions? All right, so we're going to look at more interesting functions instead of just linear functions. And we're going to try and find the domain of them. Your homework will ask you to find the operation and the domain for each problem that you have. And that's what the next page is going to help us look at. So these functions start out to get a little more interesting because g of x has an x squared. Let f of x be 2x plus 7 and g of x be 5x squared minus 6x plus 4. Find the following. Before we find the following, I want us to get the domain of these so that when we can then answer the domain of the bottom questions then of our new function. So let's first list the domain. of each function. So Ella, we have 2x plus 7. What would the domain of 2x plus 7 be? And why did you say that? Yeah, so it's just an x, that's our line. The power is 1. Ella, how about the domain of the g of x function? And that's because x squared, yeah, it's even. Any even exponent has a domain of negative infinity to positive infinity. Those are from those common functions. So even exponents, odd exponents, both of those have domains of negative infinity to positive infinity. All right, so see if you can try f of x plus g of x. And then part B says f of x minus g of x. Be really careful here because now you have quantities in these new functions that we're creating. So we have the quantity 2x plus 7. We're adding that to the quantity 5x squared minus 6x plus 4. So I now have two functions that we're adding together. You're still just combining like terms. So look across, what are your like terms? That's what you're combining together. So Cody, part A, what do you get for this 2x plus 7 function plus the second function 5x squared minus 6x plus 4?
I got 5x.
Perfect. So that would be our function when you're adding f of x and g of x together. So the domain, my original two domains were negative infinity to positive infinity. Both of them had the same domain. That means the domain of my new function is still negative infinity to positive infinity. The domains are the same. It's not going to change just because you added them together. So the second one, be really careful here with that minus sign. So you're subtracting the entire second function. So we have 2x plus 7, and then subtracting means each one of those become negative. So I'm just kind of pulling this negative through. So I'm losing the parentheses here. I have a minus 5x squared, a plus 6x, and then a minus 4. So a minus sign is kind of like distributing a negative 1 through. Eva, what did you get? Nice. And then what do you have for the domain there, Ava? Nice job. Good. Anybody have questions? All right, so working even a little more interesting with the next pair, still adding and subtracting, but this time our functions have exponents that are rationals. So function f of x is 4x to the 1/2. Function g of x is 4x to the 1/2. Now you got to think a little harder when you do the domain here. If you have an x to the 1/2, what is a different way that you could write that to try and figure out what the domain is? So x to the 1/2. What's another way to write x to the 1/2? Brooke? Yeah, so this is really saying 4 square root of x. We're going to keep it as x to the 1/2 when we go to write our function, but we need to think about the domain. So you have to think about what is that 1/2 really doing? Well, the 1/2 is the square root of x. So this is really negative 9 square root of x. What do you remember from yesterday about the radical? How do we find the domain of a square root function, Brooke? Yeah, it has to be greater than or equal to 0. Which means it can be 0 and it would go to infinity. Remember, if you have a square root, you cannot take the square root of a negative number. So that's why the domain must be at 0. You can take the square root of 0 or all the way up to infinity. So just something to kind of think about. Look at those functions. What does that exponent really mean as a radical? And then we're going to try and add them together. So we have our f of x, which is 4x to the 1/2. I'm going to go back to that exponent form, thinking about the square root just to help us get that domain. And then we're adding that with our g of x, which is negative 9x to the 1/2. So Lacey, when you add these together, what are you really adding together? Yeah. So those are like terms. They're like radicals. They're like rationals. So Lacey, when you add them together, you get. Yeah. So the x part stays the same. It does not change. I'm not adding the exponents. I'm not doing anything with the x. You're just adding the coefficients. It's the same property that we used above with adding like terms. When it's an x, you add the numbers in front. Placing an exponent with that doesn't change the fact that you're still adding the numbers in front. And then this domain has to be from 0 to infinity. Questions? So looking at part B, we're now subtracting. So we have f of x. And I'm subtracting g of x. And just as Lacey said, you're really looking at those numbers in front. So Julia, 4x to the 1/2 minus a negative 9x to the 1/2 makes. You're close, flip the sign. Positive 13 and then x to the 1/2. So my minus negative, those guys turn into a big plus sign. Double negative makes a positive. The domain isn't changing, still 0 to infinity. So questions on adding or subtracting and finding the domain. So of course, we can't forget about multiplying and dividing because that still exists. So let's look here. Multiply and divide the following functions. F of x is 6x, g of x is x to the 3/4. So I'm going to still find that domain first, trying to get you to think about what the domain of each function is individually. So the first one is just that 6x function, and we know that domain is negative infinity to positive infinity. But the next one is a little different because it says x to the 3/4. Gabby Snyder, do you remember how to write that as a radical? So I know it has to be a radical. What goes on the little chair of the radical? The 4, and that means the 3 goes, yeah, with the x. All right, so when we look at the domain, that's an even exponent. So it has the same property as a square root. Any even exponent, I cannot take the square root or the 4th root or the 10th root or the 100th root of negative numbers. So anytime it's even, it has to be greater than or equal to 0. And it's the root that matters, not the x cubed. So the even radicals all have to be greater than or equal to 0 for their domain. It doesn't matter if it's odd. Odd is okay because a negative and a negative and a negative still make a negative. But when it's an even root, it has to be greater than or equal to 0. So that means this domain, oops, I have it above, would be 0 to infinity. So even roots, it doesn't just apply to a square root. An even root has to be greater than or equal to 0. Jaden.
Would it be like the negative?
Yep. So if it's odd, you're allowed to have any number underneath there. We can ask the same question. Good question. Good. So if it's a cube root, you can have negative numbers underneath. You can have positive numbers underneath. So even is the picky one. Those even numbers. That's why I like odd numbers better. Not as picky. I wake up at 5:21 every morning. I don't like to wake up to even numbers. 5:20 just doesn't work for me. I've been that way for a long time. Mr. Kane probably just is used to it by now because he knows I'm crazy. But he married a crazy lady, so it's his fault, I guess, right? All right, so let's see if we can multiply and divide. So multiply f of x times g of x we started this chapter with properties of exponents. How do you multiply these together? 6x times x to the 3/4. So thinking in section 6.1 and 6.2, how do you actually multiply these, Jaden?
So would you make 6x, you would make the exponent 4/4 to go up to like whatever.
Yeah, so really it's 6x to the first.
And then you would do 4/4 plus 3.
Exactly. So to combine exponents, if the variable is the same, you add the exponents together. So this is really saying I have 4/4 plus 3/4. The 6 is really taking 6 times 1. So the numbers in front get multiplied together. The exponents get added. So that would make 6x to the 7/4. You can keep it as an exponent, unless it says to write it as a square root or a radical. If it's given as an exponent, keep it as an exponent. So multiply the coefficients, add the exponents. Now we have to think about the domain. One domain is negative infinity to positive infinity, but the other domain says it has to be from 0 to infinity. So what would the domain of 6x to the 7/4 be? Brooke? 0 to positive infinity. It's the overlap of the domains. My g of x function can't be a negative number. So that means when I combine them together, I still can't have a negative number because this has an exponent of 7/4, or it's a 4th root of x. So look at your two domains and kind of figure out where that overlapping would occur. So it has to start at 0 and go to infinity. And then the last one over here wants us to divide. So let's try and divide these. So we have f of x divided by g of x. Remember your properties of exponents. Ella, what are you doing when you're dividing with exponents? Yeah, you're subtracting them. So there's really a 1 in front of this x in the denominator. So you're dividing the numbers and you're subtracting the exponents. And we just said that that 1 is really 4/4. So Ella, 6x to the 4/4 over 1x to the 3/4. If you subtract those exponents, what do you get? Yeah. So 4/4 minus 1 or 3/4 gives us 1/4. And again, the numbers get divided. 6 divided by 1. That's just 6. Now, think about the domain. This one's a little trickier. This was a fraction. Even though my answer isn't a fraction, to get to that answer, it originally was in the denominator. So if it's in the denominator, x cannot be 0. So your domain is still 0 to infinity. But the 0 this time gets a parenthesis, and that's because it originally was in the denominator before we simplified it. And that's tricky to think about. So you can't always look at your answer. You have to look at what type of problem you're starting with. And we're starting with a fraction, we're dividing. So anytime something's in the denominator, it cannot be 0. So I'd like you to try those last 4 problems. This is like cheater notation. It says take f plus g. That's still saying take f of x plus g of x. Just being a little shortcut here. So try those 4 problems. Think about the domain. What's going on with that x? So what would the domain be? X to the 3 halves. So I have each of them written out here. I did not do anything with them. But I pretty much wrote the same 2 functions, put a plus, put a minus, put a times sign, and then made it a division, a quotient. So Gabby Soul, what do you get for the first one?
You would get 3x to the
Yeah, like terms, you're adding them. Add the coefficients. And then the domain, Gabby, is?
would that be equal to 0 to
Yep. So Grace, letter B, if you're subtracting 5x to the 3 halves minus negative 2x to the 3 halves, we get?
7x?
Yeah. Does the domain change? No. Same 2 functions, same domain. The next one's multiplication, so be careful. Multiply the numbers in front. If I multiply those numbers in front, I get a negative 10. Add the exponents. What is 3 halves plus 3 halves? Ella? 6 halves, and 6 halves reduces to 3. Sorry, I kind of went a little wonky there. So add in your exponents, 3 halves plus 3 halves. You add the tops, you get 6. The domain doesn't change though, because the original 2. And then the bell's gonna ring really quickly here. The last one, my x's are the same. They have the same exponents. They cancel and I get negative 5 halves. The domain just has a parenthesis with 0 instead of a bracket. So over the weekend, your homework, you have a few problems, 3 to 19, that are like these problems. Make sure you're getting the domain for each of them as well. Have an awesome weekend. See everybody on Monday next week.
Have a nice day.
Thanks, you too.